Hi everyone and welcome to CG Buildup, and in this tutorial I'll be explaining how to use the map range node found in the utilities pack inside Geometry Nodes. Without any further ado, let's get onto it. So what I have here is just a group input basic cube, and we're going to use this sort of connection that I framed in this place here, and this is just simply to view the numbers that will be changed by the map range node. And here's just a basic default cube with some settings here just to make some viewing numbers through these nodes here useful. You don't really need to know how these nodes work. All you need to know is to just understand how the map range node works. So first thing, I'm just going to add in a curve line and set it here and delete the group input. And from this curve line, instead of going in the Z direction, I'm going to prefer to go in the X direction. So I'm just going to type in 0 in the Z, and in the X I'm just going to type in 2 meter specifically. Okay, afterwards I'm just going to resample this curve to something like 12, and this is going to make the spline to have more resolution for a demonstration that I'm about to show you right now. So afterwards I'm just going to grab this over there and I'm going to capture an attribute. Okay, so capture attribute, and I'm just going to change it to vector here. Okay, then afterwards I'm just going to add in a set position node. So this is just adding more resolution, and this is going to capture information that will be lost due to the set position node that I'm going to add. Afterwards I'm going to add in a map range node. Okay, what we are to talk about. Then I'm going to connect this first to a combine XYZ. Okay, I'm going to keep this value here in the Y, and from this I'm going to connect a spline parameter node and set it to factor and connect it there. And if you're not familiar with what the spline parameter node does, it's just that we have a spline here. At the very end here, at this point, it assigns a value of 0 always, and at this is the start point, it assigns the value of 0, and this at the very end point here, it assigns the value of 1. Okay, when in each spline, actually, when it is connected, when you connect the factor, and when it comes to the length, it assigns the spline length, okay, of the spline that we are dealing with. And when it comes to the index, it assigns sort of like the number of points inside the spline minus 1 in the very end points, and in the very middle, the points in the middle, which are not the start points or the end points, are going to be assigned based on the interpolation between 0 and the values like 1, the spline length, and sort of like the number of points inside the spline minus 1. Simply that. And we're going to see what this map range node is going to do, sort of change those values. That's what the utility nodes normally do. You know, you input a value into them and they sort of do their calculation and interpolate them and give different results. That's why they're called utilities, you know, very useful nodes. So I'm just going to wrap this here, and to better view what's happening, so I'm going to connect this factor into the X, and I'm going to connect this vector into the value, and I'm going to connect this input, okay, actually this input before the set position, and I'm going to connect it there. Okay, and I'm going to connect this attribute here to this connection, and if I just click here, we can see a set of numbers that are happening. These numbers here, the first ones here in this row, are the numbers from the spline parameter factor, and in the values in the x from this combine x, and the ones at the bottom here, these values here, are the ones that are from the y. And to better view what's happening, if I play with this value here in the max, you can clearly see what's happening in the bottom. Okay, so that's for demonstration how this thing is going to work. And afterwards I'm just going to join these two together. Okay, and I'm just going to connect this one and connect it there, and let's view from the group output rather than the group from the viewer node, and simply like that. I'm just going to wrap these annotations, and let's now really dive in on what the map range node does. So if you're familiar with linear interpolation, okay, or interpolation in short, so it's going to be very easy for you to understand this mode here. So map range node does is you connecting a value here, and it changes the value here depending on this sort of a mode of something, you know, either it's linear, stepped linear, smooth step, or the smoother step. So to demonstrate it, I'm just going to duplicate this combine xyz, and instead of connecting the x and the y, I'm just going to connect the result into this z, then connect it here into the set position. Okay, like that. You can see this a line that has happened here. Okay, and if you observe very carefully, okay, now something that you have to note is that splines, their indexes are in a continuous manner, meaning that this point here has the value of 0, and depending on the number of points here, because indexes start from 0 to a certain number, so there are like 11 points currently in this spline here. So here it's 1, it's 0, and minus 12 minus 1 is 11, so it is 0 here, 11, 1. Then the next point is like interpolation, just an interpolation of a sort. It's going to be 1, then 2, and 3, 4, and 4, so forth. Okay, till reach 11. So not 10 here, it's 0 here. Okay, so and so forth till we reach 11, depending on the number of points I have here. So simply what's happening is that the spline, the map range changes the points on how they are, the points values that we input from here, depending on the number of points you connect, the interpolation of sort, I'm sorry, either it's linear, step linear, smooth step, or smoother step. So to demonstrate it, I'm just going to increase this count to 20. Okay, like that, and I'm just going to change this value here, this linear to stepped linear. You can see it sort of creates this sort of kind of steps here. Okay, there are like 4 stairs, the first one, the second, the third, the fourth, and if you check, actually by default we have 4 steps, and as you can, if you increase this value, you get more steps and more steps and more steps. The more geometry, the more clearer you can see what's really going on. So I'm just going to return it to 4, and there is also this interpolation of smooth step. Okay, it changes the value to stop look in this graphical manner here. Okay, then these smaller steps just makes the flow a bit smoother, as you can see. And something to note also, there is this value here, if you haven't noticed, clamp value, which I will talk afterwards. The clamp value, which is in linear and the stepped linear, it's only there, but when you go to the smoother step, there is no clamp, and neither is there a clamp in smoother step. Smoother step and smooth step don't have a clamp. And what does clamp mean? Let's get into that first. So let's observe these values at the very bottom, and to make it better, I'm just going to reduce the values to 10. Okay, and maybe go back to linear step. So as you can see, as I told you, at the very end, the spline parameter node gives the value of 0, and at the very start point here, it gives the value of 1, right? So what happens is that these values will be changed, okay, depending on how you set them here. So if you say 0, change it to from min to min. 0, the values that come here, make sure 0 is 0 in the end. That's what we are saying actually. Then if we say in the max 1 to be 1 in the end, and the resulting value will be in the same order. For example, the value here, it's written 0, and if I type in here 4, right, like that, you can clearly see 0 became 4, and here at the max, maybe I type in the number like 3 maybe, and if I go to this point here, 1 has been changed to 0, and the rest in the middle here have been sort of interpolated in a linear fashion. That's why we can see it has deformed in such a manner here. Okay, that's the meaning of linear. And so what about the clamp node that we have here? So let's just check it there. And now instead of connecting the factor, I'm going to connect in the length, and I'm going to connect it into the value. And after all that, you can clearly see we sort of have this tapering, or these values have been flattened out. And maybe let me just reduce this to better view the numbers as well. Let me just maybe write 0 and 1 like that. Okay, it sort of went in this linear fashion here, but to other I values like this at this point here, it sort of flattens it out, because actually remember our spline here originally is 0 0 throughout in the start, and 2 meters in the x direction only, the very end point. I mean, it was originally this one here. We had this point and this point only, and this had a length of 2 meters. Okay, and increasing the resolution of by the resample curve node, in this case by using count, doesn't change the length of this, doesn't alter the length of our spline that we are having here. It doesn't change the length of the spline in this case, especially when it's a straight line. So what happened is that instead of the spline parameter giving 0 and 1, it gives 0 to 2. Okay, but if we set it to clamp here, it means that it's going to only interpolate the values 0, okay, and to 1, the points which have that range of values due to that the interpolation from the spline parameter node. So for example, if we can shake a bit, let me just delete this and sort of rub this here and look at the values that we are having here, is that originally from this spline parameter index, let me also connect this length to the x, it has 0, then 0.22, 0.44, then all the way here to 1.00, 1. Yeah, you get the point. It interpolates the values in between, but from 0 to 2. But this map range node is sort of having this clamp value. It means that since you said the minimum should be 0 and the maximum should be 1, anything beyond or beneath those values are going to be clamped, meaning that they'll get the values that will be beneath 0 will have a value of the value below the value of the 2 min that we are going to assign here, and the ones beyond 1, okay, like this one, 1.11, 1.33, 1.55, will have the value of the 2max. And to see it again, instead of writing 0, let me just increase the number of points that I'm having to maybe something like 16. Then I'm going to type in here 0.3, and here I'm going to increase to 1.2, right, like that. And you can sort of see there is tapering here and sort of tapering over here. So what's happening is that we limited our values should be between 0.33, which these ones seem to be below that. Okay, that's why when checked clamp, this one here have become 0. Okay, and others here, because we limited to 1.2, and these values here seem to be higher than 1.2, then due to that they get the value of the 2max that we setted here, same as the value 1.22, because that's actually what we ordered. And if I uncheck the clamp, the interpolation goes within that range. Now there is no limiting because we didn't tell it to limit. Okay, so this can be helpful when you're trying to sort of trying to make some 3D in Geometry Node to sort of mimic a certain linear equation inside Geometry Nodes. We don't have to go so complex like y is equals to mx plus c, because this already does the calculation for you between that interpolation when it's set to linear. Now another one is the smoother, the stepped linear, okay, which is currently like that. And I can just check the clamp for now and just rub this a bit. And now let's go back to our factor and something like that. And here I'm going to type in 0 and 1. Okay, so let's check upon interpolation. So let me just view this like this. So 0 to 1, then it changes the value from 0 to 1, but instead of making a line here, okay, it sort of does interpolation, using sort of a stepped kind of thing depending on the values here. So to better view this can work for floats, and it's very logical on how it works for floats. It's very understandable. But let me just at this point just input an integer. Okay, and let me write here. Right now you can see that all points are in 0, meaning that there is no step. Okay, before this it was this, meaning that steps, the number of steps are 4, meaning that the first one, the second, the third, the fourth. Okay, but when you input 0, there is no sort of the steps are no longer there, because you indicated that there should not be any step. But if I keep increasing, you can see the another steps has been formed, and then another, then another. And these steps actually, okay, this step here formed, this steps formed, this step are sort of interpolated in the same way a linear step would be interpolated, and they are sort of grouped. Okay, and actually this is not a step, but I wanted to say that the sizes, the steps are equally sort of equally formed, meaning that there are 3 steps, and the size of this step, the size of this step, and the size of this step are sort of the same in a sort of manner, we can say. And so if that is for the integer case, let's ask ourselves, what about value? Okay, so if I type in values, I mean, what about for floats? And if I connect this value here into the steps, I'm sort of wrap this, there is no steps because it's 0. Okay, But what happens if I type in 0.1? As you can see, it sort of forms in the same way. If I type in 3 and connect this one and switch to this, you can see there is absolutely no difference. But there is a difference if I type in 3.1 like that and connect it here. Okay, and maybe increase it a bit because of the resolution was not enough. Let me increase it maybe 30. Okay, so you can see that in these cases, the first step, the third step, the fourth, the first, the second, the third step, okay, according to this value. But this one here, when you connect it to the steps, it's like there is the first step, the second step, the third, but this fourth step is sort of small, and this fourth step is dependent on this one here, the value here. Okay, it's very small in terms of its size, and I'm not talking about this kind of thing. I'm talking about small in terms of this portion here that it has. It's very small, okay, because you're saying like I need 3 steps, but there should be one very tiny step which has a sort of a proportional size of 0.3 here. That's what you are currently saying. It's very simple like that, and sort of a graphical way of representing it is this way. Okay, and it's among them, this node is actually among the most important node, and especially the linear one. The stepped linear and the other interpolation are in very rare cases. Maybe stepped linear can help you in making stairs in various situations. So another one is the smoother step. Okay, it has no clamp, and it actually clamps, because if I connect the length here and connect it here, you can see this smoothness has gone here, and the rest has been clamped, has been sort of tapered to this one, and simply like that. Smoother step makes, as the name says, a smoother step, and simply like that, that's how the map range node works. And I hope this tutorial was helpful to you who was trying or learning geometry nodes in the process, and you wanted to know what does the hell does the map range node do. And thank you for watching. See you next time on another tutorial.